Hello, so if you're new here, I'm Aiden, and this video is a second part to another video I made about reading numbers in any given base. So this video is the reverse of that, and it's about writing numbers into any given base. So in the last video, I talked about how a base tells you how many different digits there are in that base. So in base 10, there are 10 different digits, 0 to 9. In base 2, or binary, there are 2 different digits, 0 and 1. And it always starts from 0. It doesn't have to, but it just does. It starts from 0. I've got an example. See if you can work this one out. You don't have to, but I encourage you to, just to practice. So it's in base 9, wrote that down the bottom right. See if you can figure that out. I've got the answer. I worked it out before the video started. I might say it at the end. Okay, so I'm going to get into how to actually write numbers into any base. So there are a few different methods. I'm just going to show 2 of them. So the first one it's a bit basic, and it's not the best way of doing it. So I'm going to do this in binary. I'm going to convert the number 7 into binary. So the first method is just to count upwards. So I don't know, maybe you already know how to count in binary. Hopefully you do, but I'm just going to do it here. So this is 0, and it's 0 in any base. It's just always 0 because it's the first digit. I mean, unless you say that 0 is not the first digit, but it is, so it's 0. Now we count upwards to 1. That is still 1. Even in binary. So this is in base 2, remember? We're counting up in binary. And then we actually move across straight away because this is the last digit. So we go up to 10. And remember how I said 10 in base 2 equals 2 in base 10? So that's 2. Now we keep going up. Remember, we're trying to get to 7. So we're trying to write the number 7. And so we get to this, and that's 3. I'm going to stop writing that now and just count. So they're both 1s, so we carry up. That looks like 100, right? But it's actually just 4. So yeah, you can see how lower bases can be pretty inefficient at storing numbers. But at the same time, binary is cool, so it's fine. This is actually 5. This is 6. Remember, I'm following the same pattern. I've got that in other videos somewhere. That there is 7. So 7 in base 10. Is actually equal to what looks like 111. And you can put zeros at the start, but you don't need to. So that's one method, okay? Just counting upwards, and yes, it works in any base. It can be a bit tedious though. So, say 12 in base 10 equals, what does it equal in base 4? Well, I don't know. Figure it out. So 0, 1, 2, 3. These are all in base 4. That's also in base 4. And 3 is the last digit because 1, 2, 3, 4. So let's move on over here. I'm sorry, this is messy. But that's when we carry. This is 10. And that is actually 10 in base 4 is actually 4 in base 10. So let's keep going. Get to 11 and then 12, but it's not actually 11 and 12, it's actually 5 and 6 because that's 4. It's 4, 5, 6, 7, and then we carry 8. And I will show one more trick in a second, which you might notice. 20 in base 4 is actually 8. It is actually 2 times the base of the number, which is 4. It's just a trick. We're nearly there, up to 8. Just got to go up a bit more. 20, 22, but it's actually 9 and 10. Now let's move on over here. So we've got 20, 21, 20. Pretend that didn't happen. That's 22. 9 and 10, and then we've got 11, and then we've got 12. So this X here is actually 30. And so that's one method, but you can tell that this method is not really that good. because you're going to have to count up. Say, what if you have a number like this, but it's in base 10 and you want to get it into base 9? You're going to have to count for a very, very long time. So that's not a good method. So I'm going to go over the next one now. Okay, so this is the next method. I'm going to do it in binary because it just makes it easier. I also change color. So base 2, just so you remember, base 2, 2 different digits, goes up by 2 in the place value columns, and it's called binary, bi meaning 2. And so we want to get the number, I don't know, let's get the number 29? Let's go 29. 29 in base 10 equals what in base 2? What does it equal in binary? Okay, so some of you will just be able to see that and you'll just be able to figure it out. Maybe you recognize that, you know, there's a 16 that comes up. Maybe you know to just take 16 out of this. And yes, that does work. And that is another method of doing it. That's fine if you do that. But I'm just going to go over a better one. So I'm just saying it's better because it's the one that computers use, and it's the one that's more standard. Okay, so I'm not trying to cause any arguments here, but so these are the place values for each column. So the numbers, the digits go here, obviously, and we want to find out what 29 is in base 2. So what we can do is actually divide 22, not 22, divide 29, divide our number by the base. So 29, which is our number, over 2. So that's actually, give me a sec, it's 14 and a half. So that's not going to really help a lot. So that's 14.5. But what we want to do is actually ignore the 0.5. It's not really there. We just want to get the first bit, like straight up, just cut off the end. It doesn't matter. We're not rounding up, we're rounding down. We're flooring the number. So we get 14. Now what you do is, this is an iterative process, which means it repeats, so it's iterative. And it means you do the process over and over. Each repetition is an iteration. So iteration and repetition are mostly interchangeable, but they're not exactly the same thing. So this is the first iteration, and we get 14. Now this 0.5, it is actually important, but not for the 0.5 part. It's important because it's the remainder. So we want to actually know what the remainder is. So instead of 14.5, we need 14, remainder 1. And that's important. That is significant because this remainder is 1. And that actually tells us what one of our digits are. This can be 0 or 1. That is no coincidence. This remainder can be 0 or 1, which happens to be the digits in base 2 because we're dividing by base 2, or just 2. So what we get is 14 for the next iteration, and we get a remainder of 1. So what do we actually do with this? So let me write it below. So what we do is we get the 14 and we write it as the next thing to divide by 2, and we take the 1 and we take that and we actually put it as part of the answer. So it actually goes here in the ones place. So we moved from right to left, remember? When we're reading, we read from left to right, obviously, that's just how it works. But for numbers, for these, we read from right to left. Okay, so I'm going to iterate again. I'm going to show you what happens. So 14 over 2 it's 7, and the remainder is just 0. So that actually tells us that in the next iteration, we're going to use 7. So this is the next iteration, and the remainder is 0. And I told you it can only be 0 or 1 because we're dividing by 2. So that's actually a 0. And we're getting there slowly. So 7 over 2, it is 3.5, but remember we floor the number, so we rip off the end and we put it on here. So it's 3 with a remainder of 1. So 3 is for the next iteration, and the 1 goes right here. So we've actually got most of the number here. We just need a little bit more. Now let's do the iteration again. It's 1.5, but we take off the end, we floor the number, and we add in the remainder. So then we get 1 remainder 1. Let's move this over here. Let me just do this. And the next iteration process uses 1 at the top. And the remainder just then was also 1. So we put that here. Now the last thing to do is to do this. So remember, you floor the number. A half is just a half. It's 0.5. But we floor the number, so it's just 0. And then we get a remainder of a half, which is just 1. So it's 0 remainder 1. And so the next iteration uses 0, but that is just 0, so that's the end. Once you reach 0, that's it, that's the end. And the remainder, the last remainder was 1, so we put that here. That is the method that computers use most of the time for converting numbers into different bases. So what's actually happening is you are repeatedly dividing a number by 2 and storing the result, and you're just repeatedly doing that. So you get 29, 14, 7, 3, and 1. And you actually get the remainder each time. And so that's how you do it. I'm going to do it in another base in a minute. But yeah, so I do hope I did that right. I'm sure I did. But yeah, maybe you can check that. And if I'm wrong, then you can yell at me in the comments. So this number, 29, in base 10, don't always have to write that, but I will anyway, is actually 1, 1, 1, 0, 1 in base 2. Yeah, that's it. So it does look like this requires a lot of working out, but really it's not that bad. It is not too bad, because if you think about it, every single time you're doing this iteration here, every time you're doing this iteration, you are getting another digit every time. So if you're trying to get a big number, like say, I don't know, 255, that is coincidentally, it is coincidentally 1, 1, 1, 1, 1, 1, 1, 1. And I just remember that because I just do. So it's actually because 256 is 2 to the 8, to the power of 8, and that means the number below it is just 8 ones. That's something else. That's unrelated. Let's just ignore that. That's something else. So anyway, I'm going to get into another example in just a moment. Do an example in a base that is higher than base 10. So I'm going to do it in, let's say, base 12. So let's think of a number. 2,426. Just some number. I just thought of some random number. And it's in base 10. And we want to know what it... Sorry, that's messy. We want to know what it equals in base 12. So it's x in base 12. What is x? So let's figure that out. So what do we actually do? So this isn't binary. This is not base 2. This is base 12. So what do we actually do? So hopefully you remember the iterative process that I went through just before. So what we actually have to do is the same as before. So this is in base 12. Just remember that, base 12. And so we want to actually divide by the base and then find out the remainder. So it's the same. It's the same thing. And so we're just dividing by the base and getting the remainder. So just let me do that. It turns out to be 202. So notice we've gone from this number to this number very quickly. 202, and the remainder is also 2. So do you remember what you do? So the remainder is the digit that you're going to use. And so if we write the answer, say up here, we've got 112, 144. This number shouldn't be too big. Anyway, so these are the place values, and we know the first one now. It's 2. Now, let's continue. So what's our next number? Our next number to iterate through. So it's 202. So we get 202 over 12. And if you give me a moment. So the answer is 16, remainder 10. Now this is interesting because we don't, this is not a digit. This is not a digit here. This is a number in base 10. But we're talking about base 12, so that doesn't matter. This is completely okay. This is actually A. This is, it's technically 16 remainder A. But we just don't write that because we don't need to, not yet. So we know the next iteration uses, sorry about that, give me that. Uses 16, so we know that. And we know the next digit is 10, which is actually A. So we've got A2 at the moment, which is kind of interesting to look at. So anyway, let's keep going. 16 over 12. So that's just 1. And it's actually got a remainder of 4 because it can't go in again. It'd have to be 24 to go in again, but it's not 24, it's 16. So that keeps coming up. I keep bumping a button here. And so we know the next digit is 4, so we can just write that up here. And we know that the next number to iterate is 1. And so let's 12, and that's just 0 with a remainder of 1. Because it's got a remainder of 1, because 1 is what's left over that can't go into 12. So 0, we've hit the end, so we've hit the end here, and we know the next digit to write down is 1. So this number over here, 2,426 in base 10, so it has a value of 2,426 in base 10. It's equal to, well, you could say 1,482, but it's probably best to just say 1482. So it's 1482 in base 12. So that pretty much concludes this video. So there's the whole iterative process where you get the remainder, you floor the number, all of that. That is how you write numbers into any given base. It works, so I've shown that it works for numbers in a base above 10, and I've also shown below 10 for binary. So hopefully that's clear enough. I think I'll make, okay, so I think the next video will be about doing arithmetic with these numbers. So for example, what is this number in base 2 plus this number in base 2? So it's actually 12, but why is it 12? So you could convert them into base 10. You could do that. It's actually 5 plus 7. It's just 12. But there's actually another way of doing it, and I'll go into that in another video at some point soon. Not sure when, but I'll try to get to it. So hopefully this helps you a bit. And yeah, I will see you in the next one. And please subscribe. It helps me out a lot. See ya.